Tests of significance are used to check if the difference in data is real or just random. They help decide whether to accept or reject a null hypothesis. If the result is statistically significant, it suggests a real effect. Common examples include t-test, f-test, z-test, and chi-square test. In this video, I will be explaining in detail about test of significance and its key terminologies with real-life examples. Let us discuss in detail about tests of significance. A test of significance is a statistical tool used to determine whether the results of an experiment or study are meaningful and can be generalized beyond the sample data or not. It helps in making inferences about the population based on the sample. In the context of production and industrial engineering, tests of significance are often used to verify claims about process performance, quality improvement, or productivity metrics. It helps in making inferences from sample data to larger populations. For instance, if a company implements a new manufacturing process and wants to test whether it improves productivity, they can apply a test of significance to make a data-driven decision. Tests of significance are crucial in fields like production and industrial engineering for quality control, process optimization, and decision making. By verifying whether observed improvements or deviations are statistically significant. The primary goal of a test of significance is to evaluate whether the observed data provides enough evidence to reject or accept the hypothesis, helping engineers make data-driven decisions in areas like process optimization, quality control, or productivity. Let us see about the types of tests. Depending on the nature of the data and hypothesis, following types of hypothesis tests can be used. First is t-test, second z-test, chi-square test. So let us discuss in brief about the t-test. The t-test is a statistical method used to determine if there is a significant difference between the means of two groups. It is commonly applied when sample sizes are small and the population standard deviation is unknown. There are three types of t-test. First is one sample t-test, independent two sample test, and paired sample t-test. Then we will see z-test in brief. The z-test is a statistical test used to determine if there is a significant difference between sample and population means or between two sample means when the population variance is known and the sample size is large. It assumes a normal distribution. Chi-square test. The chi-square test is a statistical method used to determine if there is a significant association between categorically variables. It compares the observed frequencies in different categories to the expected frequencies, assuming no association. This test is commonly applied in quality control, hypothesis testing, and goodness of fit analysis in production and industrial engineering. ANOVA or analysis of variance. It is a statistical method used to compare the means of three or more groups to determine if at least one group mean differs significantly. It extends the t-test for multiple groups and helps identify factors affecting process performance. In production and industrial engineering, ANOVA is applied to analyze variations in production processes, machine outputs, or product quality across different conditions, such as shifts, material types, or operational methods. It aids in optimizing process parameters and improving overall system performance. F-test. It is a statistical test used to compare the variance of two or more groups to determine if they are significantly different. It is commonly applied in ANOVA to assess whether multiple sample means are equal, or in regression analysis to test the overall significance of a model. In production and industrial engineering, the F-test is used to analyze factors like machine performance, process variability, and production efficiency across different groups, helping engineers optimize operational processes and resource allocation. Now I'll discussing the key terminologies which are used in test of significance. Without understanding these key terminologies, it will not be possible to understand the test of significance. When performing test of significance, several key terminologies are used. Here is a breakdown of the most important ones along with examples from production and industrial engineering for better understanding. The first terminology is null hypothesis or H naught. Null hypothesis is a statement that assumes that there is no effect or no difference. It is the default assumptions that test aims to challenge. The purpose or goal of the test is to either reject or fail to reject the null hypothesis based on the data. Example, suppose you are testing whether a new manufacturing process reduces the defect rate in production line. The null hypothesis might be H naught. The new process does not affect the defect rate. Alternate hypothesis. The alternate hypothesis is the opposite of the null hypothesis. It suggests that there is a significant effect or difference. The purpose of this hypothesis is that it will be accepted if there is a strong evidence against the null hypothesis. For example, for the above example, the null hypothesis can be the new process reduces the defect rate, that is, defect rate is less than 5%. Level of significance alpha. Level of significance, typically denoted by alpha, is the probability threshold below which the null hypothesis will be rejected. It represents the risk of making a type 1 error, that is, rejecting a true null hypothesis. Typical values of alpha are 0.05, 0.01, 0.10. If we take alpha as 0.05, it means 5% risk of rejecting a true null hypothesis is there, means 5% chances of error are there. If we take alpha as 0.01, means 1% chances of error are there in the results. For example, if alpha is taken as 0.05, this means we are willing to accept a 5% chance of conducting that the new process reduces defects when it might not actually do so. P-value. The p-value is the probability of observing the test results or something more extreme. If the null hypothesis is true, a small p-value indicates strong evidence against the null hypothesis. Comparison with alpha. If the p-value is less than alpha, null hypothesis is rejected. For example, if we run the test and get a p-value of 0.03, while alpha we have taken is 0.05. So since 0.03 is less than 0.05, we will reject the null hypothesis and conclude that new process significantly reduces defects. Test statistic. Definition. A test statistics is a value calculated from the small data that is used to determine whether to reject the null hypothesis. Example of test statistic includes z-scores, t-score, chi-square values, etc. The values which are calculated from the formula of t-test, z-test, chi-square test are termed as test statistics. For example, in a t-test comparing the means of two production processes, the test statistics is calculated from the difference between the sample means relative to the variability in the data. Type 1 error, false positive. This occurs when the null hypothesis is rejected when it is actually true. Sometimes during hypothesis test, null hypothesis is rejected even when it is true. The probability of making this error is represented by alpha. If we incorrectly conclude that the new production process reduces the defect rate when in reality it does not, we have made a type 1 error. Type 2 error, false negative. This occurs when you fail to reject the null hypothesis when it is actually false. The probability of making this error is denoted by beta, often not directly calculated but inferred. For example, if the new production process actually reduces the defect rate, but you fail to detect it and continue using the old process, you have made a type 2 error. If you find this video useful, please like, share and subscribe to our channel to keep us motivated in creating more amazing contents. The next key terminology is power of test. The power of a statistical test is probability of correctly rejecting the null hypothesis when it is false. It is equal to 1 minus beta. For example, a powerful test in the context of a manufacturing process could correctly identify that the new process reduces defects, helping make better decisions about process changes. Critical value. The critical value is the threshold beyond which the null hypothesis is rejected. It is determined by the level of significance and the type of test, one-tail or two-tail test. For example, we will see it in detail, but here if we perform a Z test and for Z test alpha is 0.05 in one-tail test, the critical value might be 1.645. If the calculated Z score exceeds 1.645, we will reject the null hypothesis. We will discuss in detail about Z test in the coming videos. Let us understand the aforesaid key terminologies with the help of a problem scenario. Consider this problem scenario. A factory has implemented a new production process and you want to determine if this new process reduces the defect rate compared to the old process or not. The old process has a known defect rate of 5% and a sample of 200 products from the new process shows 6 defects. That is, 6 defects are found in a sample of 200 products which are manufactured from the new process. We will conduct a hypothesis test to determine whether the new process significantly reduces the defect rate or not. For the above problem scenario, to perform the test of significance, following steps can be followed. First of all, we will select a null hypothesis, that is, null hypothesis states that there is no significant effect or difference. In this case, it assumes that the new process has not reduced the defect rate. That is, the defect rate of the new process is equal to or greater than the old process defect rate. Then we can select alternate hypothesis also. Alternate hypothesis claims that there is a significant effect or difference. It asserts that the new process has reduced the defect rate. The defect rate, we can write alternate hypothesis as H1, the defect rate of the new process is less than the old process defect rate. The third step in test of significance is selecting the value of level of significance. As we know, the level of significance is the threshold for rejecting the null hypothesis. Commonly, it is set at 0.05, though it may be taken as 0.01 or 0.10. It indicates the risk of making a type 1 error. In this example, we can choose alpha to be 0.05, meaning that we are willing to accept a 5% chance of concluding the new process reduces defects when it might not. The next step is p-value. The p-value is probability of observing the test results or something more extreme under the assumption that the null hypothesis is true. A small p-value indicates strong evidence against null hypothesis. Using a standard normal distribution table, the corresponding p-value can be calculated, which I will be explaining while solving the problems. If the p-value is greater than the significance level, alpha, we fail to reject the null hypothesis. This means we do not have enough evidence to conclude that the new process in the given example reduces the defect rate. Next step in test of significance is calculation of test statistic. The test statistic is a value concluded from sample data to compare against a critical value. In this case, the test statistic can be calculated using z-test. Though the value of test statistic is calculated based on the test we opt. If we opt for t-test, t-value is calculated. If we opt for z-test, z-value is calculated as test statistic. The z-score indicates how many standard deviations the sample defect rate is from the old defect rate. Summary. We reject the null hypothesis if either the test statistic is more than the critical value or the p-value is less than or equal to the significance level alpha. We fail to reject the null hypothesis if first the test statistic is less extreme than the critical value, or the test statistic value is less than the critical value, or the p-value is greater than the significance level alpha. One common problem faced while performing test of significance is the difference between one-tailed test and two-tailed test. So here we will try to understand one-tailed test and two-tailed test with the help of an example. Consider this scenario that the efficiency of a new production machine is being tested, and you are a production engineer evaluating the efficiency of a new machine. The current average production output of the existing machines is 500 units per day, and you want to test whether the new machine's output is different from this, that is 500 units per day, and also whether it improves the output. You collect data from the new machine, and after a week, you calculate that the average production output is 530 units per day, with a standard deviation of 40 units over 30 days of observation. So, with the help of this example, we will see how to perform one-tailed test and two-tailed test for this example problem. So, let us see first how to write two-tailed test for this problem. That is, testing it if output is different from 500 units. In two-tailed test, we will only test if the output is different from 500 units, not less than or more than. So we will write the null hypothesis that the mean output of the new machine is equal to 500 units. This will be our null hypothesis. H naught mu equal to 500. Similarly, we will select an alternate hypothesis that the mean output of the new machine is not equal to 500 units. Here we have not selected that mean output of the new machine is more than 500 unit or less than 500 unit. We have only selected that the mean output of the new machine is not equal to 500 units. That is H1 new is not equal to 500. This will be our alternate hypothesis for this example. Let us see for the same example how to write one-tail test. So testing if the output is greater than 500 units. So while writing one-tail test for the problem I have mentioned earlier, we can write the null hypothesis as the mean output of the new machine is less than or equal to 500 units. That is H naught mu equal to less than 500 units. And alternate hypothesis we can write is the mean output of the new machine is greater than 500 units. That is H1 mu is greater than 500 units. So in one tail test, we will consider that null hypothesis is that the new machine is the production of new machine is less than or equal to 500 units, while in alternate hypothesis we will consider that the output of the new machine is greater than 500 units. So this way we can see the difference for a given with the given example that how to write alternate and null hypothesis for one tail test, for performing one tail test or for performing two tail test. Please like, share and subscribe to our channel to keep us motivated in creating more such contents. Thank you.